Alrighty, let's do some maths. So we've got y equals x squared minus 6x plus 8 over here. This is a function. That means for different values of x, I'll get different values of y. And what I'm wondering is what we can do with this function. So pause the video, spend 30 seconds and think, what can we do? Okay, so you might think, oh, it's a quadratic. What have we been doing recently with quadratics? We've been factorizing them. So that is something you could do. And we are indeed going to do that in a bit. What else could we do? Well, we could set y equal to a value, like say 0. And then we could factorize it and then solve it and get the values of x for which y is equal to 0. We could set y equal to something else, like 6, and then rearrange it. Get 0 on one side and maybe that will factorize, maybe it won't, but we could have a go at that. One other thing we could do would be to plot it, and I'd like you to create some axes like this, 1 square per unit from -2 to 8 in the x direction, -3 to 10 in the y direction, and see if you can plot this function. Hint, you're going to need to create your table yourself. So think about what values of x you might use. Pause the video now and have a go at this. Alrighty, so maybe you did it without a calculator in your head. Maybe you did it with a calculator but typing them in. Or maybe you used the table function. So if you remember, we go to menu on a calculators, assuming you've got a calculator that has this, but hopefully you do. And then you find table, which is number 3. You can either press 3 or equals. Type in the function. So it's alpha x squared minus 6 alpha x plus 8 equals. This is asking me if I want to put a second function in. No, I don't. So I'm going to press equals again. Where do I want to start? I'm going to start at -2. I'm going to end at 8. And I want to go up by 1 every time. And here we go. We get our table of values. These two columns are the ones we're interested in. X and f of x. F of x, remember, is our y, essentially. When we have -2, we get 24. Well, that doesn't fit on the graph, so it's all well and good, but we're not going to use that in our table. -1 gives 15, which is also off the graph, but 0 gives 8 and 1 gives 3. So I'm going to write those down. Okay, my calculator disappears off the screen when I do this, so just bear with me. Okay, next ones, keep going down. We've got 2 gives 0 and 3 gives -1. Okay, write them again. 4 gives 0 and 5 gives 3. Okay, keep going. 6 gives 8, and then 7 gives 15, which is off the graph. So I'm not interested in that one. Let's just write down the one for 6. That gave us 8. Okay, we've got a table, and now we can plot the values. We can plot that 0 is against 8, 1, 3, 2, 0, 3, -1, 4, 0, 5, 3, 6, 8. And those, I'm going to use a slightly thinner pen. These are our values, but that's not the graph. That's just a bunch of values that appear on the graph. The graph actually exists for other values of x, so we're going to draw a line freehand that goes through all these points. Okay. Oh, that's not bad at all. Okay, that is my graph. I've plotted a quadratic function. Okay, today is not about plotting quadratic functions. It is about sketching quadratic functions or graphs. What is the difference between plotting and sketching? Well, plotting is when we do it really sort of exactly. We get all the points. We know it's really accurate, whereas sketching is sort of doing it more quickly, but having the main things in there. So, you might sketch a picture of a book, and as long as someone can identify that as a book, then you've kind of succeeded, to be honest. It might not be perfectly proportioned and, exact and have all the shadows and lighting on it, but it's a good representation. That's basically the difference between plotting and sketching. So we don't want to create tables, but we want to have the main features of the graph. So my question is, what are the key features of this graph? And I want you to pause the video and have a think about that. Okay, so I would say that the key features of this graph are, first of all, the shape. Now, every single quadratic that is like an x squared has a shape like this. So as long as, if you asked me to describe it, I would say it's like a U, and I would kind of think that, oh, this is probably a quadratic. I call this a smiley quadratic. It's like a little person smiling. This is opposed to another kind of quadratic, a minus x squared graph. There might be some other terms after it, like there are here, but the minus x squared will mean that it is a sad quadratic. We're only going to touch upon these today, but I just wanted to put that out there. So that is a key feature. Another key feature is my y-intercept. And this is basically where it goes through the y-axis. So here, and it's a bit like when we do y equals mx plus c. The c bit is where it goes through the y-axis. It's the same for this graph here. Okay, it's going to go through at 8. So that is something that would be useful to tell me if I was sketching the graph. Another thing that would be useful would be the x-intercept. In this case, there are 2 of them. There might not be 2 of them. Okay, so I'll put S there because generally there will be 2. In this case, we've got 2 and 4, and if I knew what they were, then I'd be able to, help me sketch this function. And then finally, the turning points. What do you think I mean by the turning point? If you look at this graph, well, we mean this here. Okay, because we basically now know the graph's coming down like a U. We know where it's crossing the axes, and this just tells us where it starts turning back up. Okay, good. So my question, this question is, how can we work out these key features from just the function? Imagine we didn't have the graph, I hadn't already plotted it, and we can't just read off 8, 2, and 4, and this coordinate here, which is 3 minus 1. Didn't add that before. How can we work it out just from this function? And this is the magical bit of the lesson. It's amazing. It's just like 1 minute you got algebra, next minute you got geometry. How can we do it? Well, basically, this is what we're going to do. We're going to talk through it. So the shape. We get the shape for free by just finding out this next squared. So I've already spoken about that. The y-intercept is 8. We also basically get that for free. It's just a number by itself. So whenever if I change this to a 7, then the y-intercept would be 7, and it would cross at 7. So hopefully those 2 are okay. The second 2 are the trickier bit, the most interesting bit, I think. So the x-intercepts. What is going on? How are we going to get this from the graph? Okay, we can see that the x-intercepts, the y value is equal to 0 at this point. So when I want to work out the x-intercepts, I'm going to set y equal to 0. In this case, I'm going to have to deal with the fact that x squared minus 6x plus 8 equals 0. And hey presto, I have created a quadratic equation that's equal to 0. And we know we need to solve this to get my values of x, and we know how to solve this. Hopefully we do anyway. To solve a quadratic, first of all, we've got it equal to 0, so we've done all that stuff. I'm going to still set it equal to 0. And then we need to factorize it. That is the really efficient way of solving quadratics. I know I'm going to have an x. I need two things that multiply to give 8 and add to give minus 6. Because this is positive and this is negative, they're going to have to both be negative. It's going to be minus 2 and minus 4. And that then means that x minus 2 is 0 or x minus 4 is 0. We're multiplying two numbers together. It must be that one of them is 0. And that gives us the solutions x equals 2 or 4. Wow, wow, wow. That's what we got here, 2 and 4. So I get the solutions by solving a quadratic equation. Okay, I don't need to plot it. I can just factorize, set it equal to 0, factorize, and solve it. Okay, what about the turning point? This is maybe the trickiest bit, but hopefully it will make sense. I'm going to talk through it now. So basically, any quadratic is a sort of a symmetric curve. There's actually a line of symmetry that goes through it, and if I reflected this part of the curve and this line, it would look exactly the same. And if you notice, the turning point is also going through that line of symmetry. And there's one other thing. This line of symmetry is exactly halfway between the two X intercepts. And we can use that to help us find the point. So basically, if I want a turning point, it's between, do you know what, not just between, halfway between. No, I don't like that either. It's the midpoint of the X intercept. And we get the midpoint or the median by adding them together. Adding the X intercepts together. So it's going to be 2 plus 4 over 2, 6 over 2, which is 3. Here you can probably just sort of see that 3 is halfway between 2 and 4. But if I gave you more complicated numbers, then this would be a good way of doing it. So we get the value of 3. We're not quite there, because for the turning point, it's also useful to find the y value. So when x equals 3, we would then substitute that value of 3 into the back into the function. So it would be 3 squared, which is 9, minus 6 times 3, which is 18, plus 8. 9 plus 8 is 17. 17 minus 18 is minus 1. We've got the y value as well. So this is the most advanced bit of the sketch, but that's what we're also going to find that out. And we get 3 minus 1 in this case. So I'm just going to backtrack because there's a lot of information. We've got a quadratic function. We could plot it, which does an exact job, but takes a bit of time and needs a calculator. Or we could sketch it, which is just going to give us the main features of it. And that's, those are what we need. We get the shape quite quickly by looking at whether it's an x squared or a minus x squared. We get the y-intercept by just looking at the number. We get the x-intercepts by setting it equal to 0. Okay, setting y equal to 0 and then solving it, which we'll solve by factorizing, and then we get the solutions. And finally, we can get the turning point by finding the point in between the two x-intercepts for the x value and then substituting it back in for the y value. Whew, quite a lot going on there. But finally, like if I wanted, so what do I mean by a sketch? I'd just get rid of this graph. Now I'm not going to bother labeling my graph. I'm just going to draw my axes. I might put some arrows in. I've got x and y. And now what I would do is I'd put my 8 in. I would put my x-intercepts in of 2 and 4. I would put the coordinate of my turning point And that is all I need for my sketch. I can then say, right, it's going to come down like this, it's going to go back up, and that's my sketch. Okay, I think I could do a slightly better job than that, but it illustrates the idea. So very, very quickly, we can get the idea of what the shape of the graph looks like. Okay, we've covered the main ideas about sketching. So we're going to do 3 more examples just to really hit home how to do this and get the procedure going. It comes with time. Okay, we're going to sketch y equals x squared minus 3x plus 2. First thing is the shape. It's going to be a happy quadratic. Second thing, we're going to get the y-intercept. I'm just going to call it the y-int, and that's going to be 2. And then we need the x-intercepts, and I'm going to set y equal to 0, so x squared minus 3x plus 2 equals 0. I'm going to factorize this. Again, positive here, negative here, so they're both going to be negative. And then either this bracket is 0 or this bracket is 0, which is going to give me x equals 1 or 2. I've done all this without a calculator so far. Turning point, I'm going to write TP. That's going to be halfway between 1 and 2. It's going to be 1.5. And then all I need to do is put my 1.5 back in to the function. Probably going to need my calculator for that, so get my calculator back in calculating mode. 1.5 squared minus 3 times 1.5 plus 2 minus a quarter or minus 0.25. Okay, same method that I used before, just like more concise and quick now. This is the working that I want to see from you. So I can then plot that. So I'm going to put, I mean, doesn't have to be to scale. It's just sort of an indication of what's going on. What does this curve look like? I know it goes through at 2. I know it. Okay, I'm going to stretch this out a bit so I can see it better. I've got 1 here. I've got 2 here. And then I know that it's going to go through this point here, which is 1.5 minus 0.25. Yeah, I know it's negative. And then that is enough information. I know that it's going to come down, it's going to go through that point there, it's going to turn, it's going to come back up. I should really have made it symmetric, so let me just extend that and maybe just cross that out or rub it out. So that looks better. Got a line of symmetry now, and that's my first sketch done. Brilliant. Okay, second one. Right, so I've done 2 with like standard kind of ones. I'd say I'm going to do the ones that, like, it's not that they're more difficult. They're just a bit like the ones that trip people up because they forget about them. So first of all, shape. This is a happy quadratic. Secondly, the y-intercept. Right, that's going to be the number, but that is actually 0. Okay, so I know it's going to go through the origin. The x-intercept, that's going to be when y is equal to 0. Do you know what? I regret doing that. I'm going to write y-intercept and then write 0. Okay, x-intercept y equals 0. That's going to be when x squared plus 4x equals 0. And so I then need to factorize it. I actually don't have a number here, but I have a common factor of x. So it's going to be x bracket x plus 4 equals 0. Don't forget, this gives me a solution of x equals 0. When x is 0, I get 0 here. Or x is minus 4, coming from this one. So I know, but it's already given me, I've already got this point, but actually it's given it to me again. But now I've got this other point of minus 4. The last one is the turning point, and that's going to be x equals minus 2, because it's the point that's halfway between 0 and minus 4. I'm going to substitute that in. I'm going to work this one out in my head. It's going to be minus 2 squared plus 4 times minus 2. Minus 2 squared is 4, and I'm going to minus 8, so I'm going to get minus 4 coming out. Okay, so I can go in between and just put it down here, and I'm just going to label it with a coordinate. And that is my key points are done. Now I need to draw the quadratic in. There we go. I'm happy. Okay, last one. This kind of one. So now we don't have any x's, but we've got an x squared and we've got a number. Don't let this trip you up. It's another happy quadratic. We get the y intercept is going to equal minus 16. I know it's going to go through this point here. The x intercept is when y is equal to 0, so it's when x squared minus 16 equals 0. I need to solve this. Two ways you could do this, actually. You could either set x squared equal to 16, and you could take the square root, so x is plus or minus the square root of 16, plus and minus 4, or you could factorize it. I prefer factorizing it because that's what we're going to be focusing on. X minus 4, x plus 4 equals 0. This is a difference of two squares. That's the standard sort of way you factorize it. And again, we get x equals 4 or minus 4. So I know it's going to go through this point at minus 4, and it's going to go through this point at 4. In this case, the halfway point is actually 0, and I've already got my turning point. I don't have to do an extra bit for my turning point. So you might say these ones are actually the easiest one. And then to draw it, that was a shocker. Try it again. Really concentrate when I'm drawing it on here. So, okay, there we go. I've got all the key features of my quadratic, and that, ladies and gentlemen, is how we sketch quadratic equations. Hi, this is a quick video just to talk more about the shape of quadratics. So I talked about Smiley Quadratics and sad quadratics. So starting out, this is y equals x squared, and this is a Smiley quadratic because it's like a U sort of shape. You can see it as a smiley face if you add some eyes and a nose. If I could draw some other ones, I could draw y equals x squared plus 6x minus 3, and that's another smiley quadratic. It's just in a different sort of place, and this is what we're getting at with sketching quadratics. We're getting different places where they cross the axes. This one actually doesn't cross at nice whole number answers, but hey, that sometimes happens. If we do another one that does, so y equals x squared plus 5x plus 6, this one does. It goes through minus 2 and minus 3. I know that because I can factorize the quadratic. But in any case, there's another smiley quadratic. So what are these? Oh, and the reason that it does this is that when x gets big, what term is going to dominate the most? It's going to be the x squared term, okay? This is going to get bigger as well, but this one, because I'm squaring something, it's going to be really big. And so as x gets bigger, y gets bigger, and it's going to go off to infinity. As x gets bigger in the negative direction, then when we square a negative, we get a positive again, and it still goes up in the y direction. Okay, sad quadratics. An example of a sad quadratic is minus x squared. So now, instead of being a u, it's sort of like an n. It's been flipped around, and basically any quadratic which has minus x squared as the starting point will be I've drawn one that's quite high up here, will have this shape. Okay, I'm going to do one more. So if I do y equals minus x squared minus 5x minus 6, then this one goes through minus 2 and minus 3. Again, it's a sad quadratic. So it's all about this term here. Now, why does it do this? because now I've got my x squared, which is going to be really big for large x, but I'm making it negative, so that's why it's flipped around and become negative. If I've got negative x, then I'm squaring a negative number, so like minus 10 all squared is 100, but then I'm making that negative, so that's why it's going to look like that. So I hope that just adds a little bit more about why quadratics look like they do.